Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome back to my YouTube channel. My name is Septiari. I'm from Chemistry Class A with NIM 210603110036. I will talk about sampling strategy water and wastewater analysis, contamination and loss in water analysis, contamination from leakage. First, sampling strategy water and wastewater analysis. Sampling strategy and preservation. Sampling is collection and a certain volume of a water body to be studied with the smallest possible amount but still representative and still has all the same characteristics as the water body. Sampling is divided into the following three steps. The first, representative sampling. Two, transport and preservation of sample. Three, chemical analysis of sample. Next, preparation of sampling and preservation. Bottles that will be used to take sample must be clean and have rinsed with the distilled water first, then followed by the liquid that will be used to fill the water and dry, if possible. The same also applies to sampling equipment, such as pipes, pumps, must be clean and do not contain residue from the odd sample. Especially the growth of mold and mildew must be prevented. Contamination from metal or sampling equipment, which may dissolve in the sample, must be prevented. Iron, brass, bronze can be dissolved in acidic or alkaline water, while plastic and rubber material are soluble in industrial wastewater containing organic solvent or oil and gasoline. Sample can be taken separately using a bucket, plastic or glass bottle, opened in white, for example with a lead ring around the neck, tied with a rope, then put into a river canal well unsealed. Taking sample at a certain depth, provided with a closed bottle that can be opened when it reaches the desired depth. Another way is to use a type of pump that sucks. Sample from faucet can be taken with an open beaker or bottle to be closed depending on the analysis plan. Automatic sample. Special tool for consecutive sampling consists of sucking pipe, limited sampling point depth of about 5 meters below the tools, pump, clock to control sampling frequency, tool for dividing sample in a bottle format sample, isothermic box containing bottle of mixed sample by cooling by ordinary ice or dry ice, so the sample preservation can be done no later than 1 day before being brought to the laboratory. Samples shall be filed in the collection vial to the brim and the vial closed properly to avoid contact with it. One common way of processing sample is cold condition. Samples are transported in an isothermal box containing ordinary ice or dry ice CO2 and then stored in the refrigeration or freezer. Disturbances that can arise during the storage and transportation of samples. Gases such as O2 and CO2 can be absorbed by the sample water or can be separated from the sample water into the air. Suspended and colloidal substances can form their own flux and precipitate so that there are samples that are different from the original state. Unless the starch must be suspended again evenly before analysis by shaking the storage bottle. Like substance and liquid, mud, gases, oil, and sweat can float on the surface. Some solids can be oxidized by dissolved oxygen to turn into the compounds. For example, dissolved Mn2 plus can be oxidized by oxygen to MnO2, which can precipitate to that it is lost from the solution. Some solutes can reach from, for example, Ca2 plus and CO3 to mean can be become CaCO3, which precipitate. This happens when the pH value changes. For example, because CO2 levels are not constant, or because of a growth. The method of preserving sample depends on the analysis to be carried or the elements to be studied. 2. Contamination and loss in water analysis. Contamination and loss in water analysis. Contamination is defined as the introduction of noxious compounds into the sample during the sample pre-treatment process and during analysis. Source of contamination in the sample can come from atmosphere, operator, equipment, water, and regions. Contamination from the atmosphere. Primarily, they derive from particular trace elements on the soil surface and suspended material in atmosphere. The simplest way to avoid an atmospheric contamination of the sample is to cover the sample solution during the preparation and analysis process. Contamination by operator. Analysis can be a source of contamination to the sample to be analyzed either by direct contact or through the air. NENCL can be transferred to be sample through the operator's breath, dust, and cigarette smoke source of metal contaminants. Powder, lotion, perfume, including operator clothing and such, can become contaminated. Human skin is reported to contain metal even in very low concentration. Masks, clothes, laboratory coats are usually worn to reduce contamination. Contamination from equipment. Glass war. Glass in analytical chemistry means borosilicate glass such as PRX unless otherwise specific. Contamination of sample from glass is usually caused by acidic dissolution of the container by the solution. Pyrite is resistant to weak acid and base but less resistant to strong acid and strong base. For the analysis of Si, B, A, oil, Na, and K shall not use Pyrex bottle. HSG glass, high silica glass, is more resistant to solution and heart attack up to 900 degrees Celsius. Washing glassware using a 1:1 mixture of H2SO4 and concentrate and SNO3 is better than a mixture of Cr2O7 and H2SO4. To keep glass contamination to a minimum, equipment should always be stored and soaked in a dilution solution, mean 0.1 mol HCl or HNO3 when not in use. Hot HCl or HNO3 can be used to clean the glass surface from metals. Other preparation equipment that is often used and has a lower probability of metal contamination are first silica quartz. First silica quartz can be used at high temperature and is safe from metal contamination. The possibility of contamination comes from material that have been absorbed by silica in previous use. 2. Plastic. Polyethylene and polypropylene, resistant to attack by most regions use, not resistant to heat content additives, antioxidants, UV absorber, and other compounds to assist mixing and fabrication. Teflon, tetrafluoroethylene polymer, can be used for temperature up to 300 derajat Celsius, inner to almost all analytical regions. PVC, polyvinyl chloride, contain metal with high NOx level, for example, zinc and 70 ppm, Va270 ppm, Sp3 ppm, Cu 0.6 ppm. Also report to contain Pb, Sn, Cd, and Ti. Most plastics are contaminated with polymers such as zinc. Zinc started on the surface, so they need to be cleaned before use. 5. Rubber is the rubber. It is recommended not to wash rubber equipment in the trace analysis. Rubber contains adsulfides such as zinc oxide, antimony compounds, and Pb compounds. Filter paper. Most filter paper contain a number of metals with varying contents. Contamination from water. Because water is used in very large quantities compared to other ration greater than 100, it is necessary to pay special attention to the purity of the water used, especially in trace analysis. To reduce metal contamination the water needs to be passed first into the ion exchange pool or released to distillation. Contamination from regions. Contamination from regions can be grouped: 1. Mineral acid and ammonia, inorganic solid, organic reagents, organic salt. Mineral acid and ammonia. Mineral acid. Most mineral acid contain great amount of metal. Extra pure acid contain metal in very low level. Generally, reagents with this quality have a fairly expensive price. Ultra pure generally contain very low metal concentration, but the contents of some elements varies from product to product. Analytical reagent grade acid usually contain the metal listed in the table. A. Ammonia. Ammonia solution in water placed in a glass bottle will be contaminated by silicon, aluminum, calcium, and other elements which might be caused by acid by alkaline solution on the glass. Analytical reagent ammonia can contain heavy metal in very low concentration. Zn 0.005 ppm, Pb 0.003 ppm, Cu 0.005 means 0.2 ppm. This is probably due to the absorption of the metal by the glass. In inorganic solids of varying quality are usually poured enough to be used carefully without pre-purification, but a plain contour solution must be prepared. Pb is an important metal. The content of this metal is usually found in solid KCl, NaCl, NH4, NO3, and KNO3. Analytical reagents ranging from 0.1 to 0.3 ppm. Purification is usually by crystallization or filtration. Reagent organic. Organic reagent, silicon. Silicon agents usually contain metals that are coordinated in coordination. These metals are usually derived from solvent or reagents used in the synthesis of reagents. Organic or complex reagents are usually used in small quantities so that contamination can often be neglected. But caution is necessary at using the reagent as a plate. Concentration and expressed in selection. 1. Tritazone, Carbon, sodium diethyl bicarbonate, phenol trifluoroacetone, hydroxyquinone. Next, organic solvent. The metal content in organic solvent is usually relatively low, which must be watched out for is the presence presence of the organic compost dissolved in the solvent because it usually interferes with the determination of spectrometry. For example, CCl4 and CHCl3, if left unhacked, will produce COCl2 oxidation result, which will interfere with the determination of metal by the detection method. Loss analysis. During the preparations, aeration, and determination steps, the analyte may be removed from the sample solution by the following factor: 1. Absorption, 2. Volatility, 3. Co-precipitation or precipitation. Thank you for your watching. Don't forget to subscribe, like, and comment. Have a nice day. Bye.